Hello everybody, we'll be learning about rational numbers today. This is part 1 of the chapter. We'll have part 2 and part 3 which will cover all the details of the chapter as well as NCERT exemplar questions for the chapter. I'll also provide you with the homework so you'll need to do those questions regularly. Also, I really hope that you remember all the concepts of rational numbers that we have done in class 7th. We'll start with what we have to do in class 8th. If you remember, rational numbers are the numbers which can be expressed as a ratio of integers. Few examples will be 1 by 4, 2 by 7, 3 by 10, 34 by 7, and you can enumerate so many of them. I would like to tell you how rational numbers came into being. So, if you solve equation like 3x plus 5 is equals to 0, you get the solution as minus 5 by 3. And I hope you know that minus 5 by 3 is neither a natural number, nor it's a whole number, nor an integer, which actually led us to the conclusion that there is yet another set of numbers which are known as rational numbers. And these are the numbers which can be expressed in the form of x by y, where x and y are integers and y is not equal to 0, which basically means that the denominator cannot be equal to 0. We'll discuss properties of rational numbers now. The first one being the closure property. When any operation is performed between two or more rational numbers, the result is also a rational number. Then we can say that rational number follow closure property for that operation. Or I can also say that rational numbers are closed with respect to that operation. Next we come to commutative property. When two rational numbers are swapped between one operator and still the result doesn't change, we say that rational numbers follow commutative property for that operation, or you can also say that commutativity holds for that particular operation. Next we come to commutative property. Commutative property holds when rational numbers are rearranged between some operations and still the result remains same. We can also say that associativity holds for that particular operation. Now we'll discuss the role of 0. When any rational number is added to 0, then it will remain the same. That is, x by y when added to 0 will remain x by y. 0 is therefore called the identity for addition of rational numbers, or you can also say that it is the additive identity of the rational numbers. There's an example shown in which 2 by 3 when added to 0 will remain 2 by 3, and so will be another example of minus 5 by 7. Now we'll discuss the role of 1. When any rational number is multiplied with 1, then the result will remain the same. X by y multiplied with 1 is equals to 1, where x by y was a rational number. 1 is therefore called the multiplicative identity for the rational numbers. This example of 2 by 7 when multiplied with 1 will remain 2 by 7. There's another example of minus 8 by 3. So both the examples show that 1 is the multiplicative identity of the rational numbers. Next we come to negative of a number. When a rational number is added to the negative, or you can also say its additive inverse, the result will be 0. That is, x by y when added to minus x by y will give you 0. There's an example shown of 2 by 7 when added to minus 2 by 7, the result is 0. Next, we'll learn about reciprocal of a number. When a rational number is multiplied with the reciprocal, or you can say its multiplicative inverse, the result will be 1. That is, x by y multiplied by multiplied by y by x, the answer will be 1. There's an example of 2 by 7 when multiplied with 7 by 2 will give you fun. So basically, reciprocal and multiplicative inverse are one and the same thing. Next, we'll come to distributive property of multiplication over addition. If the rational numbers a, b, and c obey the property of distributivity, that is, a into b plus c, the answer will be a into b plus a into c. It will set to follow distributivity or distributive property of multiplication over addition. Also, I would like to tell you that distributive property of multiplication over subtraction is also true. There's an example here, and you can easily use BODMAS techniques to solve this, and you can verify that distributivity holds for multiplication over addition and multiplication over subtraction. We'll have all the properties at a glance now. A number of p by q form, where p and q are what? Integers, and q, the denominator, is not equal to 0. Basically, there is a number line showing the rational numbers. So there is a positive side of the number line and the negative side of the number line. There is a table here which shows all the properties and the various operations under which you'll verify if these properties are true. We'll start with closure property. So in case of addition, if you add two rational numbers, the answer will be a rational number. If you subtract two rational numbers, the answer will again be rational number. Multiplication. In case of multiplication, if you multiply two rational numbers, the product is again a rational number, but this is not true for division. If you divide two rational numbers and you take b as 0, then you know it won't be a rational number. So there is a condition. If b is non-zero, then it will be a rational number, but in case b is 0, then it will not be a rational number. Commutativity. Let's talk about commutative property under addition. So you already know a plus b will be equal to b plus a, but a minus b will not be equal to b minus a. Multiplication will have both the sides as equal. A into b will be equal to b into a. But in case of division, a divided by b will not be equal to b divided by a. So what you get to know is that commutativity holds under addition and multiplication, but not under subtraction and division. In case of associativity, it has a similar trend as commutativity. So under addition, it holds. Under subtraction, it doesn't hold. In case of multiplication, again it holds true, but in case of division, it doesn't hold. So commutativity and associativity have similar trends. They hold under addition and multiplication, but they don't hold under subtraction and division. Now comes distributivity. Distributive property, as I've already told you, holds under multiplication, under addition, and multiplication over subtraction, but they're not applicable for multiplication and division. Now we'll get to know how to use these properties so we can ease out the calculations. There's an example here which shows 2 by 5 multiplied by 3 by 7 minus 1 by 6 multiplied by 3 by 2 plus 1 by 4 multiplied by 2 by 5 again. What you notice is that 2 by 5 is common in the first and the last term. What does that mean? That if you combine these two terms together, you'll be able to solve them. But when you shift places, when you change places of the terms, you have to use commutative property. Or you can also say that you are rearranging them. 2 by 5 multiplied by 3 by 7 plus 1 by 14 multiplied by 2 by 5, and the second term goes at the last. Now you need to use distributivity or taking common. So what was common? 2 by 5 was common. So 2 by 5 is taken as common, and what is left inside? Minus 3 by 7 plus 1 by 14. If you further solve it, You'll use BODMAS techniques to get the answer. There are two similar questions here. If you solve them and you'll use the properties of commutativity and distributivity, you'll get the answers as 2 and minus 11 upon 28. And don't forget to mention the properties, as I'll not give you full marks if you don't write the properties. The properties names carry marks. Now we'll start with NCERT exercise 1.1. The first question is given here, the first part and the second part. First, we'll solve the first part. If you try to recall, this is a question based on the usage of the properties that we have done. If you look closely, 3 by 5 is common in the first and the last term. So what we'll do is we'll shift the middle term at the last. If you see closely, 5 by 2 has been shifted at the last. You can write regrouping or you can also write commutativity. Now what you notice is 3 by 5 is common. So under the bracket remains minus 2 by 3 minus 1 by 6. And if you take something as common, you basically use distributive property. So you'll mention the name of the property. 3 by 5 multiplied by, and you'll solve this by taking the LCM, and after solving, you'll get the answer as 2. Similarly, we'll solve the second part now. Second part will also use these two properties, commutativity and distributivity. If you look closely, 2 by 5 is common. So you'll take 2 by 5 as common and you'll get the answer by using commutativity, which is regrouping, and distributivity and usual BODMAS techniques, and you'll get the answer. Next, we have question number 3, in which we need to verify that minus of minus x is equals to x, where there are two values of x being given. The first is 11 by 5 and the next is minus 13 by 17. Here, when x is equals to 11 by 15, minus x will be minus 11 by 15, and minus of minus x will be minus of minus 11 by 15, and you already know that two negative signs combine to form a positive sign. So this becomes 11 by 15, which is nothing but x. So this verifies the question. Next we have minus 13 by 17. So minus of x would be minus of minus 13 by 17. Two minus signs again will become positive and it becomes 13 by 17. So minus of minus x would be minus 13 by 17, which is nothing but x. Hence verified. We have question number 4 now, in which we need to find the multiplicative inverse of the following. So as you already know that multiplicative inverse is a number which multiplied when with the number gives the answer as 1, which is the multiplicative identity. So minus 13 when multiplied by minus 1 by 13 will give you the answer as 1. So multiplicative inverse is basically the reciprocal of the number. So here it is shown that minus 13 multiplied by minus 1 by 13 will give you the answer as 1. Next part is minus 13 by 19. The multiplicative inverse of minus 13 by 19 will be minus 19 by 13. Why? Because if you multiply these two numbers, the answer will be what? The answer will be 1. Next, if you come to multiplicative inverse of 1 by 5. So 1 by 5 when multiplied with 5 will obviously give you 1. So multiplicative inverse, or you can say the reciprocal of 1 by 5 will be 5. Now we come to the fourth part. Fourth part, if you see, is minus 5 by 8. So, minus 5 by 8 There is another thing here, multiplied by minus 3 by 7. So what you'll do is you can either multiply them and then find the multiplicative inverse, or you could find the multiplicative inverse of each one of them and then you can multiply. Suppose it was minus 5 by 8, so its multiplicative inverse would be minus 8 by 5. Why? Because minus sign always remain in the numerator. Minus 3 by 7 similarly will have the multiplicative inverse as minus 7 by 3. And if you multiply these two, you'll get 56 by 15. As I just told you that there's another method. So alternatively, what you can do is minus 5 by 8 into minus 3 by 7, which is 15 by 56. And the multiplicative inverse of 15 by 56 is 56 by 15. So as you can see, minus 15 by 56 multiplied by 56 by 15 will give you the answer as 1. So you get the same answer in both the ways? Yes, you do. Next part, which is minus 1 into minus 2 by 5. And if I ask you, what is minus 1 into minus 2 by 5? Which is obviously 2 by 5. So the multiplicative inverse of 2 by 5 will be 5 by 2. Since 2 by 5 multiplied by 5 by 2 will give you 1, which is the multiplicative identity. Next, the sixth part, multiplicative inverse of minus 1. And if you take the reciprocal of this, it will be 1 upon minus 1. But since you know that minus sign always remains in the numerator, so the answer will be minus 1. So multiplicative inverse of minus 1 is minus 1 itself. And now here itself, I ask you, what is the multiplicative inverse of 1? So what is the multiplicative inverse of 1? It is 1. So the two rational numbers which are their own multiplicative inverse are 1 and minus 1. Now we'll come to question number 5. You need to name the property under multiplication used in each of the following. So the first one, if you see, minus 4 by 5 into 1 is equals to 1 into minus 4 by 5 is equals to minus 4 by 5. So basically you're changing places, and I've just told you if you change places, it is known as commutativity. In the second part also, it is commutativity. But in the third part, basically, there is a rational number minus 19 by 29, which is being multiplied with 29 by minus 19, and it is giving you the answer as 1. So they are basically multiplicative inverses of each other. So this is multiplicative inverse property. Multiply 6 by 3 by the reciprocal of minus 7 by 16. And if I ask you, what is the reciprocal of minus 7 by 16? It is 16 by minus 7. But the minus sign will obviously shift to the numerator. So it is minus 16 by 7. Now you need to multiply two rational numbers, and you have done multiplication of rational numbers in class 7th. So if I ask you, what do you do to multiply the rational numbers? You multiply the numerators together and the denominators together. There is absolutely no need to find the LCM. LCM is found for addition and subtraction, not in case of multiplication and division. So here you need to multiply 6 by 13 with minus 16 by 7. And if you multiply them, you'll get minus 96 upon 91. Since multiplication of a positive and a negative number will be a negative number. This is basically a rule of integers. Next we come to question number 7. Here you need to tell what property allows you to compute this as this. So if I ask you, if you remember associativity property, there we rearranged. So here also, what are you basically doing? A into B into C will be A into B and then multiplied by C. So this is associative property of multiplications. So It's basically associativity. Question number 8 now. Is 8 by 9 the multiplicative inverse of minus 1, 1 by 8? Why or why not? So here we need to solve. Minus 1, 1 by 8, as you can see, is a mixed rational number. So what you need to do is you need to convert this. How will you convert this? 8 into 1, which is 8, plus 1, which is 9 upon 8. But there was a minus sign also. So you'll put the minus sign as it is. Next, you need to show that whether it is the multiplicative inverse of it or not. So what do you do? How do you prove that it is the multiplicative inverse of it or not? You will multiply them, and if the answer is 1, then it is the multiplicative inverse. Or you can also say that multiplicative inverse of 8 by 9 is 9 by 8. How did the minus sign come into being? So this question is wrong. So it is not the multiplicative inverse. The correct multiplicative inverse would be 9 by 8 or 1, 1 by 8, not minus 1, 1 by 8. Now we'll come question number 9. This question asks if 0.3 is the multiplicative inverse of 3 1 by 3. Again, it asks you the reason for it. So, solution would be 3 1 by 3 would be equal to 10 by 3 and 0.3 would be equal to 3 by 10. So, if you multiply 10 by 3 and 3 by 10, the answer will be 1. So, if you multiply two rational numbers and the answer is 1. So that basically means that the multiplicative inverse of each other. Now there is a homework for you. Exercise 1.1, question number 2, 10 and 11, and also example 1 to example 5. I hope you understood all the concepts and you will be doing this homework today.